All right, in this video exercise, we are applying a horizontal dilation, a scale factor of 4 to the function y equals x squared. Now that's a parabola that's already been drawn up here. We can see it here in red, y equals x squared. So we're going to apply the horizontal scale factor of 4. But first, what is a horizontal scale factor? Well, basically what it is what it says. It's a factor. So what happens is it's 4 times, when we apply 4, as wide as the original parent function of y equals x squared. So if our y equals x squared looks like that, if we spread that out 4 times as wide as this, it's going to be that new function. So there's 2 ways to do it. I'm going to do it mathematically up here by applying a little rule down here. I'm going to show you in a moment. And the second thing is we're going to draw a little table of values and plot it up here so you can visually gain a representation up here on the number plane. So first, let's take a closer look at this scale factor of 4 right here. We're going to do it mathematically, and we're going to apply this right over here. All we need to do in order to transform this function by a horizontal scale factor of 4 along the x-axis from left to right, make it wider, is take that 4 and put it underneath the x. In other words, it's x divided by the scale factor. So it works like this. We have y equals x squared, so all we have to do is go y equals x all over, what's the factor? 4. It's inside the function, and then we put brackets, and then we put the squared. Why? Because this is inside the function. So that 4 must go inside the function, not outside. So therefore the 4 inclusive is also squared. So that's our new function. Y equals x on 4 squared. Some people can represent it as y equals 1/4 x brackets all squared, which is the exact same thing. Now, we're going to draw a table of values so we can see what it looks like up here. Now, mind you, because it's a factor of 4, we know it's going to be stretched, not compressed. It's going to be further away from the y-axis than the original parent function, that is y equals x squared. So let's draw a table of values. So the table is going to involve the x, we're going to have an x value, and we're going to have the y equals x on 4 squared. So we'll have an x over 4, all in brackets, the whole thing inclusive, all squared. So let's so the values I'm going to put in here, I'm going to start off with probably the values of, we'll start off with 1. Yeah, we'll go 1, 2, 3, 4, 5, and then I'll jump across to 8. It's pretty much the same thing. Okay, so let's put some lines in here. Okay, let's start substituting. We're going to substitute x equals 1 into this. X equals 1, x on 4. So that's going to be 1 over 4, so it's 1/4 or 1/4 all squared. What's that going to give us? 1/4 all squared is going to be a small number, roughly, on your calculator. It's going to be about 0.06. Okay, let's put 2 in there. 2 over 4 is 1/2. Half squared, or a half squared is going to give a half times a half. That's going to be 1/4. I'll just write it as 1/4. Let's put 3 in there. 3 over 4 is 3/4. 3/4 squared is going to give me 0.56. Let's put 4 in there. 4 on 4 is 1. 1 squared is 1. Let's put 5. 5 on 4, all squared, is going to give me 1.6. Let's jump over to 8. 8 over 4 is 2. 2 squared, 2 2s is 4. Okay, let's plunk these values on the right-hand side, and then we can mirror that because it's a symmetrical function here, so we can do it on both sides. So 1, 0.06. 1, 0.06, that's pretty low, that's about there. We've got 2, 1/4. 2, 1/4 is about there. We have 3.56, 3.56. We have 4, 1, 4, 1. 5, 1.6, 5, 1.6, and then 8, 4, 8, 4. Now if I mirror that across the other side, if I take that across there, 1, that's going to be there, that's going to be there. 1, 2, 3, 4. 1, 2, 3, 4. That's going to go there. That's going to go there. And that is going to go up there. So if I join the dots here, it's going to look like that. So as you can see, it is stretched, not compressed. So what's the function doing? It is stretched. It's a dilation that's stretched, and it's 4 times as wide as the original parent function. Now, how can we confirm that it's 4 times as wide so we can gain more clarity? So if you want to understand this better, I'm going to pick 2 points on the same horizontal line. So let me just pick the point. Where does it go through? A nice point here, 8, 1. So we're going to put an 8, 1 right there. And right here we've got 2, 4. So 8, 4, sorry, and then 2, 4. So let me put a mark at 2, 4 right through there. So they're the 2 points. So the scale factor is 4. So we're talking about 4 times as wide. So let's count the number of units. Well, the first one is across at 8. On the horizontal, it's 8 units away from the y-axis. 8 units. And here, the original parent function is 2 units away. So 2 units of 8, that means it's 4 times as wide as the original function. So 2 compared to 8, it's 4 times as wide. So that confirms it. And if I pick another point, let's say I pick the point over here, 1, at 1, 1, and I pick another point at 4, pretty close to 1. 4 is 1. There we go. 4, 1. Again, same horizontal line. The new function is 4 times away from the y-axis than the original one, which is 1 time away. So that's 4 to 1. So again, that represents the scale factor of 4. Hope that helps you gain better understanding. And the function again is y equals x on 4 all squared.